Okay, all of you, I welcome you all to the chemistry online class. In the previous class, we have discussed the conduction in metals and the conduction in electrolytic solution. And in this class, we are going to discuss the specific conductance, new concept of electrochemistry chapter first. Okay, the specific conductance. Uh, from the discussion in the previous class, it is clear that the electricity or electric current is passed through the electrolytic solutions due to the transportation of ions towards the respective electrodes when we apply the potential difference, to the two electrodes, or when we supply the electric current, when we pass the electric current through the electrolytic solution. Okay, that electricity is passed due to the transportation of ions, moving of ions towards the respective electrodes. Okay, cations attract towards the cathodes, anion attract towards the anodes. That part we have discussed in the electrolysis process. Now, according to as the electricity flows in the metallic conductors, the electricity also flows and obeys the Ohm's law. Okay, Ohm's law. Now, what that Ohm's law suggests, or that Ohm's law is stated as the electric current, the amount of electric current passed through the solution is directly proportional to the amount of electric current. Ohm's law. Ohm's law. What Ohm's law suggests? Ohm's law is stated as the amount of electric current which is represented by I. Okay, the amount of electric current is directly proportional to the, or it is given as E upon R, or in the statement, Ohm's law is stated as the amount of electric current passed through the solution is directly proportional to the potential difference between the two electrodes and inversely proportional to the resistance of the electrolytic solution. Okay, resistance of an electrolytic solution. This is the Ohm's law. Ohm's law, once again I will repeat the statement. Ohm's law is stated as the amount of electric current passed through the solution is directly proportional to the electromotive force, or in other words, electromotive force is nothing but potential difference between the two electrodes. Okay, when we create the large potential difference between the two electrodes, then and then only electricity flows from high potential to low potential, and the force which causes the electric current to flow, that force is nothing but, it is said to be electromotive force, which is caused due to the potential difference, in between the two electrodes. Okay, and this amount of electric current passed through the solution is directly proportional to the potential difference and inversely proportional to the resistance, where E is potential difference between the two electrodes. Or this is also called as electromotive force. The force causes the electric current to flow from high potential to low potential region. Okay, and here R is resistance. Resistance of a conductor. Okay, as every conductor has the conductivity, it has certain resistance or resistivity. What is resistance? It is the ability of the conductor to stop or to cease or to resist the flow of electric current. म्हणजे प्रत्येक कंडक्टर कडे एक अशी ability असते जे की इलेक्ट्रिक करंट फ्लो करण्यापासून त्याला थांबवण्याचा प्रयत्न करते किंवा त्याला रेजिस्ट करते. त्याला आपण काय म्हणतो? रेजिस्टन्स ऑफ अ कंडक्टर इज the ability of that conductor to resist the flow of electric current, to stop the flow of current, to make the obstacles for the electricity to flow through the solution. That ability or that potential of that conductor is known as its resistance power. Understood? It is very important. From this point only we are going to proceed or approaching the concept of specific conductance. I hope the Ohm's law is clear to you. Ohm's law, I is equal to E upon R. That means how much electric current passes through the solution, that can be determined by this ratio E upon R. Means if greater the electrode potential difference or greater the potential difference between the two electrodes, one electrode is having high potential and another electrode is having low potential. If the difference is greater, then large amount of electricity passes or more amount of electricity passes through the solution. Okay, as well as if smaller the resistance of the resistance means its ability to resist the flow. Electric current pass करण्याला थांबवण्याची क्षमता. The ability of the conductor to resist the flow of electric current, that is called as resistance. And smaller the resistance, greater the electric current passing through the solution. Okay, here R can be defined as R is a resistance, and which is represented by a letter capital R and which is measured in terms of ohm. Resistance of a conductor is expressed in terms of, or the unit of resistance is ohm. Now, this resistance of any conductor is directly proportional to length of the conductor and inversely proportional to the area of cross section. A stands for the cross sectional area of the conductor. Once again I will repeat, the resistance, okay, conductivity, the amount of electric current passing through the solution is inversely proportional to resistance. Means smaller the resistance, greater the electricity will pass through the solution. But what is resistance? It is the ability to seize the electric current to pass through the solution, to resist the electric current to pass through the solution. And again, the resistance of a particular conductor depends on the two factors: the length of that conductor and the area of cross section of that conductor. Okay, now greater the length, greater the resistance, smaller the area of cross section, greater the resistance. म्हणजे काय? This resistance of any conductor directly proportional to length. That means greater the length, greater the ability of that conductor to carry the electric current, to pass the electric current. Now, again, resistance is inversely proportional to A. That means greater the area of cross section, smaller will be the resistance. Or in other words, vice versa, smaller the area of cross section, greater will be its area of, greater will be its resistance. Okay, means for a conductor, if it has the low resistance means its length should be short and area of cross section must be greater. Okay, then only you have low resistance. Or this resistance can also be given as R is equal to rho into L upon A. Here rho is proportionality constant. Where rho is a proportionality constant. Okay, proportionality constant. If the length of the conductor is 1 centimeter, okay, if length of the conductor is 1 centimeter and area of cross section means if suppose this is the conductor and this area of cross section, overall area of this conductor, okay, if the area is greater, then the resistance will be smaller, or the any metals, simple भाषा में एक बारीक तार है, मोटी तार जाड असलेली तार will carry the more electric current, and बारीक असलेली तार काय will, it will resist. Now this is called as the area of cross section, okay, and if the area of cross section of the conductor is 1 centimeter square, 1 centimeter square, then 1 centimeter square, then the R can be given as this R. If we put the value of L and A in this equation, what we will get? R is equal to rho. R is equal to rho. Where R is the resistance and rho is the specific resistance, which is also called as specific resistance. Why it is specific resistance? Why it is said to be a specific resistance? Because we have specified the length and the value of length and area. Okay, when we specify the area, specifies the values of length of the conductor and area of the conductor, then whatever the resistance shown by such a conductor is said to be its specific resistance. I hope it is clear. Okay, in simple words, if you look at this equation, the resistance is equal to rho into L by A, where rho is the proportionality constant, or when we specify the values of L and A, then R becomes equal to rho. That rho is called as specific resistance or specific resistivity. Okay, specific resistivity of a conductor. Specific resistivity of a conductor. Therefore, R is equal to rho when the length is equal to 1 and area is equal to 1 centimeter square. 1 centimeter square. That is known as resistance or specific resistance. Now, as we know that the conductance of any conductor is inversely proportional to the conductor of any conductance is inversely proportional to the resistance. Okay, conductance is inversely proportional to resistance. Obviously, if any conductor is having high resistance, that will flow the less amount of electric current through it. That will allow the less amount of electric current through it. जर त्याची resistivity खूप जास्त असेल तर त्याचा conductance काय असेल, कमी असेल. Or if the resistance is low, then its conductance is high. That is the meaning. As already we know that the conductance of any conductor is inversely proportional to the resistance of that conductor. Smaller the resistance, greater the conductivity. Therefore, every conductor must have very less value of resistance, and to have the less value, this L value and A value decides the resistance of that conductor. Okay. Now, therefore, C is equal to 1 upon R. C is equal to 1 upon R. If we put the value of R in this equation, okay, what we अगोदर equation काय होतं, R is equal to rho into L upon A. Therefore, if we put the value of R in this equation, what we will get? C is equal to 1 upon rho into what will it becomes, okay, capital A upon L. This is the conductance. Okay, this is the conductance. Now, but 1 upon rho is the 1 upon rho is the conductance, or we can say whatever the conductance we get. Now, if we fix the value of A and L here again, if we fix the value, if we specify the values of A and L once again here, then what we will get? The conductance of the solution is equal to 1 upon rho, where rho is the specific resistance, where rho is the specific resistance, and here we can say that specific conductance is inversely proportional to the specific resistance. Okay, what is the specific conductance? Specific conductance is inversely proportional to the specific resistance, and with this specific conductance is equal to 1 by rho. That means specific conductance is inversely proportional to specific resistance. Now, if you put the value of this rho in this equation, then we will get the value of 1 upon R into L upon A. This specific conductance is denoted as the symbol K. K is equal to 1 upon R into L upon A. This is the mathematical expression of specific conductance. K is equal to 1 upon R into L upon A. Specific conductance. Up here we derived equation for specific conductance, which is inversely proportional to, yes, obviously conductance is inversely proportional to resistance. Similarly, specific conductance is also inversely proportional to specific resistance. Very simple. If we put the value of rho from this equation, then we will get this equation 1 upon R into L upon A, where K is the specific conductance, R is the resistance, L is the length of conductor, and A is the area of cross section of conductor. And therefore, the specific conductance now can be defined as the specific conductance of a conductor is defined as it is the specific resistance. 1 upon R is nothing but specific resistance. 1 upon R is nothing but it is the specific resistance of a conductor having length is equal to 1 centimeter and area is equal to 1 centimeter square. Okay. Once again, I will repeat the definition. What is the specific conductance? From this equation, specific conductance is defined as specific conductance of a conductor is the specific resistance of a conductor having length is equal to 1 centimeter and area is equal to 1 centimeter square, or in another terms, I would say the specific conductance of a conductor. Obviously, here conductor is a electrolytic solution. Therefore, how much quantity of solution is said to be the specific conductance, or how much quantity of solutions conductivity is said to be a specific conductance. That is nothing but the solution of 1 cubic centimeter solution, or the specific resistance of 1 cubic centimeter solution is known as specific conductance. Specific resistance of 1 cubic centimeter. 1 cubic centimeter solution. 1 cubic centimeter solution is known as specific conductance. And the units of this specific conductance, obviously 1 upon R. That means 1 upon ohm into L centimeter and centimeter square. Okay, then it will be per ohm per centimeter is the unit of specific conductance. Ohms per centimeter, or it can also be ohms. Ohms per centimeter. Are internationally accepted unit of specific conductance is Siemens. Internationally accepted unit of specific conductance is Siemens. These are the three units. Okay, the unit specific conductance can be expressed in terms of Siemens per ohm per centimeter or ohms per centimeter. This is all about the specific conductance, and here we will stop. And if you have any doubts and any problems to ask, then you may ask.